Welcome back to part 2 of the video series talking about the requirements for the SCS 4 exam. For this portion, we're going to cover the second half of the first portion of the requirements in TP 2293 listed here. The first portion of the topics is a bit of a recap of the previous material we covered. They're asking about different meanings of different displacement terminology. So, the terminology I gave in the previous presentation, talking about displacement equals lightweight plus deadship, basically want you to know that load displacement is synonymous with the final displacement, and similarly the light displacement is synonymous with the ship's light weight. And dead weight we already covered, which is the weight the ship carries of fuel, cargo, ballast, etc. The next portion of the requirements for this section is talking about how to use a deadweight scale. So looking at the picture in front of us right here, it does seem quite complicated as to what's going on. Just to go through the overall formatting for this one, the name of the vessel itself is the MPV, not even going to try and say that. Their IMO number is 9436226. Above that we can see their assigned load lines. Talking about load lines will be a secondary topic for a further presentation. The main dimensions of the ship is length between perpendiculars is 112 meters long, its breadth is 16.5 meters, its height is 8.3 meters, and molded depth is 6.28 meters. All that will be discussed in a different presentation as well. Looking on the top of here, we see various columns. The leftmost is draft in decimeters. So a decimeter is just 10 centimeters, so in this case 60 would be 6.0 meters. Additionally given is draft in feet for those of you who still like to use archaic units. Displacement in tons, dead weight in tons, tons per centimeter immersion, which we're going to discuss after this, tons per inch immersion, moment to change trim by 1 meter, metacentric height, and draft in decimeters once again. So looking along these gives the ability to readily find information about the displacement corresponding to certain drafts, what the TPC is depending on what your draft or displacement is. One other note I should talk about here for this, the various densities of water affect the displacement of vessels. So you can see inside here, displacement is given in fresh water for tons, as well as dead weight given in fresh waters for tons. So that'll vary based on whether you're using fresh water, brackish water, or salt water, hence why there's columns available for each of these. Example of how to work it. So if you're talking about a draft of 6 meters, you want to know your corresponding values for this. So you work your way to the right along the columns here. You can see that displacement in tons for fresh water, down the scale, it's about 8950 tons. What about salt water? 9,200 tons. Our dead weight for this vessel, in fresh water, 6,075 tons. In salt water, 6,300 tons. Our tons per centimeter immersion, roughly 17.87 tons per centimeter. So you can see it's quite a simple scale to use. It's a matter of drawing a fine line across it. If you had any of these values, you could work your way across the scale to find the other unknowns. So the topic we're going to talk about now is tons per centimeter immersion, otherwise known as TPC. The definition of this is the amount of tons of cargo that must be discharged or loaded to effect a change in mean draft of 1 centimeter. We're going to go through the quick derivation for this of how it's determined for a box-shaped vessel. So consider the below vessel I have drawn here. Its length is 100 meters, its breadth is 10 meters, there's a draft of 1 meter. If you look from the top at this, we can see that the overall area of the water plane is equal to the length times the breadth. That gives us an area of 1,000 meters squared. So we now know that we have the area of water plane equal to 1,000 meters squared. Think about it right now as if it's a piece of paper in front of you and you want to make it 1 centimeter thick. So you know the volume required to do that would be the water plane area times the depth. So if we have the 1,000 meter squared water plane area, we want a depth of 0.01 meters or 1 centimeter. It gives us a volume for this small slice of the vessel of 10 meters cubed. So we know we need to displace an additional 10 meters cubed of water. So what weight is required for this? In this case, we're going to talk about salt water having a density of 1.025 tons per meters cubed. So the formula for this is weight equals volume times density. So our overall volume is 10 meters cubed times the density of 1.025 gives us an overall weight of 10.25 tons. So this tells us that our tons per centimeter immersion for this box-shaped vessel is 10.25 tons per centimeter. Or in other words, if we were to load 10.25 tons of cargo, our mean draft would increase by 1 centimeter. Now that we've talked about the TPC for box-shaped vessels, let's talk about actual ship-shaped vessels. So we know that for an actual vessel, the hull does not resemble a box. On the right here is this example of different kinds of vessels. Something you see mentioned here on the right-hand side, the block coefficient, CB. We'll be talking about that in the later video, but essentially, if the CB equals 1, we're talking about a box-shaped vessel. As the CP tends towards 0, that gets more and more fineness for the hull form itself. So you can see inside here, high-speed planing craft 0.35 versus a heavily built workboat 0.65, so looks more boxy than that. Getting back to the topic of TPC, we know just looking at these right here, as the draft of that vessel changes, the area of its waterplane will change as well. If the area of the waterplane is not constant, it's therefore implied that the tons per centimeter immersion must change with changing draft. Hence why in the deadweight scale you can see how the TPC is varying based on draft. So recapping what we've covered today, we've talked about the light displacement, load displacement, definition of deadweight and displacement tonnage. We've used our deadweight scale to find the deadweight and displacement at various drafts. We talked about the theory behind tons per centimeter immersion, as well as why it varies with draft. What we're going to talk about in our next video, if you come back for that one, is how to actually work with the TPCs to find out various information about changes in draft as we load our discharge vessels. Thank you for your time. Draft.